Oh, it's interesting. For those of you who have accounts with Parse, you probably saw the email about. So what's interesting about that? I mean, first of all, what I've been telling people is you have a year. So I think a lot can happen in a year, and since they're releasing migration tools, somebody's bound to step up and create a Parse compatible cloud computing platform. So I don't know if I would start a brand new project with Parse, but if you have an existing one, I don't think it's that big a deal to immediately jump ship. But what's kind of interesting when you look at the politics behind it from the perspective of kind of these big companies, when Facebook originally bought Parse from the original makers, this was like soon after Facebook's initial public offering, and their stock was kind of in the dumps, and people were trying to figure out how does Facebook actually make money and all this stuff. So I think Facebook was kind of grasping at straws on, what's the next big thing in terms of revenue for us. So they buy a cloud computing company, I think, to compete at the enterprise level with like an Amazon and a Google. So with the mindset that, okay, well, we're going to take this relatively consumer, small-scale app developer cloud computing platform, and we're going to beef it up to make it compete with the big boys. Well, then in the meantime, Facebook figured out a whole bunch of other ways to make money. And now they've kind of turned that whole problem around. So now they're rolling in the dough. Their stock prices quintuple what it started off as. So now it's kind of like, well, even though Parse was a good idea on paper, now it's not really worth our time, or money to focus on it. So what originally looked like a good idea from a Parse user perspective, like, oh, well, a big company bought Parse, so that's validation to the tool. Now it looks like it was the worst thing that could have happened for Parse, because now the big company doesn't have to worry about the income from Parse, it's just dumping it. But we'll see. You have a year before it completely shuts down. I'm sure somebody will step up and set up their own server. What's this? Oh, cool. You got to print it out for me, and it should be on nice paper.
It's on Slack.
And it should probably say Dr. Michael Littman, PhD, not Mike Littman. I mean, my credentials should be included.
Of copyright? You have a PhD?
No, my name should have a PhD in it. I'm just saying that, this is a continuing education type of thing. When a dentist goes to something to learn about the newest, latest, greatest camera technology, gets the thing, it's going to be such and such DDS on the certificate of completion.
So would you saying it should be like Dr. Michael Littman, FAT?
Exactly. Something along those lines. All right, so let's keep chugging here. Let's see, where did we leave off last time? We talked about the single directory hierarchy. Talk about that guy?
Yep.
Okay, so that's different from a non-POSIX compatible OS like Windows, where you have your multiple hard drives, each kind of have their own individual file system within them, right? Your C drive has your, the Windows normal directory structure. Single directory hierarchy and POSIX operating systems combine everything into one and kind of make everything look like files. Did we talk about this? Or is this where we stopped?
That's where we stopped.
Okay, so various file types, and this is kind of what I was just saying, is in a POSIX OS like Unix, everything looks like a file. That way they are able to consistently deliver I/O functions that work on file descriptors, where a file descriptor could be attached to any sort of actual animal, where that could be a device, it could be a socket, it could be an actual file, it could be all sorts of different things because they all look like files. All right, so we have regular data files, we have actual devices, we have pipes, which are kind of communication channels between processes on it. We talk about it again probably later on in here. We talk about inter-process communication. We have sockets, which are communication channels between processes that are not necessarily on the same host computer. We have directories, which are kind of a list of files. They contain files. They contain a hierarchy, so they're going to have some sort of data structure that defines what's inside of them, but it's a file at its core. Then we have these symbolic links, which effectively are pointers that point someplace else. Okay, so CWD, this is a Unix command. It tells you current working directory. So if you're ever out at the Unix prompt and you want to know where you are in the world, you type CW. Oh no, it's actually PWD, it's present working directory. So I should change that to PWD. CWD would indicate the current working directory, but the way to get at that is PWD, which is the present working directory. Let me change it. So present working directory. Files and directories have permissions associated with them. Did we talk about this last time?
Yeah, we did.
Okay, so we weren't on that screen that you told me we were on.
Yeah, I knew
You
that.
lied to me.
Yeah.
No, we were there.
No,
I didn't get through.
Because then we went through and did all the files and that stuff.
Well, I think you skipped down like 4 slides and then ended.
Okay. Yeah, so here's these permissions that are over here. The first thing is whether it's a directory or not. Then it's the owner, what permissions they have, the group they're in, what permissions they have, and then everybody else, what permissions they have in terms of read, write, execute. So, so files and directories have permissions associated with them, and this would be related to the chmod command. Change the mode of a file. Three bits for read, write, execute. So kind of what I mentioned a second ago is one of the reasons why we treat everything in a POSIX OS as a file is so that we can provide a standard I/O suite of functions where it doesn't matter if we're talking to a plain Jane file or if we're talking to a device. We still open it the same way, we read from it the same way, we write to it the same way, and then we rely on the interfaces on either end to interpret those things in the correct way. So from a programming perspective, I/O is always done the same way. So we can kind of rely on bytes to come in, and then we have to, if we know the nature of what we're getting is bytes that need to be put together, then it would be on us to kind of corral those bytes together in some sort of, perhaps a string, something like that. If it's an image file we're building, then we might start filling up a file, writing bytes to that file, that kind of stuff. So in Windows OSs, there is a specific EOF, end of file character. So when you're reading from a normal file in Windows, you keep reading until you actually reach that end of file character. Whereas in POSIX OS, there isn't a specific end of file character. You just know you've reached end of file when you try to read something and there's nothing there. You receive a zero data, null. Okay, so again, that's to support that universal I/O approach of POSIX. All right, so file descriptors. This is again in support of the universal I/O. Effectively, what we do is whenever we open up an I/O device, we, as part of that open system command, we get a file descriptor, which is a kind of a specialized integer. So if we opened up 10 things on the system, the last file descriptor we get would likely be the number 10. All right, that's the unique number of that I/O thing, whether it's a device, a file, whatever it is. That is the unique way we can reference it from that point forward. Okay, so once we've opened it, the system remembers the file descriptor associated with it. All right, there are 3 default file descriptors that are opened by default as part of the init process when the OS first launches. And that is standard input, standard output, and standard error. Okay, so these exist even on a Mac. So if I'm, let me just clear this real quick, and I'll make it a little bit bigger. I wonder what just happened there. Oh, I think, did I hit X and press enter? Is that what you saw? Probably tried to, let's go ahead and do a hard reset on this. Probably to try to relaunch the X windowing environment, the Mac graphical user interface. Oh, yeah, you can do it. I got tired of waiting. I decided that that process was now dead to me. There we go. All right, so I'm just going to go back to, I'm in my home directory here, so let's say that, let's see, what files do I have here? Here's a test.java, so let's just do a more test.java. There's some stuff in there. All right, so I can cat test.java. Oh, you guys had a homework assignment. What does cat do? It just spits it out to the screen, right? So I can cat this, and this goes out to standard output. Standard output is the what's on the screen. I can redirect standard output like this into another file. So let's say redirect.txt. So now instead of it going to standard output, I redirected that standard output into redirect.txt. So now if I cat redirect.txt, which just got created, that has that stuff in it. Similarly, I can redirect the second output stream. Oh, it was Tony behind you waving. You don't have eyes in the back of your head? They issue those when you get PhDs. All right, so now I'm going to cat test.java, which is by default going to go out to the standard output stream. And what I'm going to do is I'm going to redirect the second output stream, which is system.error, to redirect.txt. So when I do this, what should we expect to see on the screen? I should see everything that is from standard output. So I should see everything from test.java displayed to the screen, and only the aspect of standard error from the cat command gets redirected. So I should see everything, and then the redirect.text is empty because there was no error messages there. But if I had an error message and I redirected it, then I would get a, in fact, I should just try this. Bad command, redirect that to redirect.txt. So now I should see command not found. So I took standard error, which was that was when it was going to yell at me on the screen. So standard error and standard output both come to this terminal screen. So the terminal screen is actually showing the output of two different output streams. Standard out and standard error. Well, I redirected standard error to redirect.text. And I did not redirect the standard output stream, but there was no standard output stream associated with that because I made up a command. It would have been pretty funny if that was not a made up command. It would be kind of a funny like virus to write for somebody like on a computer where it becomes a catch-all program that replaces the standard terminal interpreter, so like the shell, and anything it doesn't naturally know what to do with, it just pretends it does, and like randomly selects from like, you know, maybe 14 or 15 different like strange user interfaces that pop up, you know, but like
just delete a random file every time.
Or, but no, I mean, like really trick them. Like, you know, it pops up and welcome to Southwest Airlines customer, secure flight status or something like that. We played that trick on my neighbor last year. He's really, really paranoid. My neighbor is like a high stress, paranoid type person, and you know, he won't go out of the house certain times because of that stuff. And you know, whenever he sees a cop like drive by, he thinks they're after him. He sees them like if a cop's parked on our street, you know, probably the guy's sleeping or something. he starts flipping out. So we changed the SSID of our wireless router to FBI van number 7. So he starts seeing this pop up.
You gotta change the name of the terminal that you're at to FBI headquarters or something like that.
Well, and the other thing, because I also have access to their wireless network because they're on Uverse and I'm on Time Warner, so if one of us is down, the other one. So he has an Apple TV that I set up for him. So I could AirPlay to his Apple TV. So him and his wife are always over there watching these like British TV shows and stuff like that. So I could AirPlay in and have just something like just show up, and it could just look like an FBI van dash cam or something like that, showing his house. I haven't done this yet, but this is a great idea. All of a sudden, I'll just start getting text messages from him. It's like, what's going on? It's like, I don't know, Hans, but something just flew through my window. These are great ideas.
You should like rent just a windowless white van.
Just set it out there.
It should change the DNS server on its router so it redirects to one of yours, and it just redirects to a web page that you have that says FBI.
I don't know that he really knows how to use the web, so I'm not sure he would ever actually recognize
He
that.
doesn't know how to like check his email or something.
He does, but he would just do it from his phone, and I don't know if he ever actually joins Wi-Fi. I think he thinks they're after him. It's a strange situation, but you go up to this van, you just have like a weird soundtrack playing just constantly on a loop in there, just like gurgling and like power tools. Where you just hear people talking, and every now and then they like name drop his name.
Just get a bunch of students to go sit in an ice cream truck and just sit outside his house for a few days.
Okay, so in any case, these are these file descriptors, which are non-negative integers, just unique IDs of these different files in a POSIX OS. 3 of them are already set for us by default because they represent standard input, which is from our keyboard. That's the standard way of talking to a computer. Standard output, which is to the screen, and standard error, which is also to the screen. But those are come over 2 separate output streams so that if you are interested, you could separate them. You can have all your error stuff logged in a log file somewhere, and you can have all your normal output still get to the screen. So that's why you have 2 separate versions of that. And the C library, standardIO.h, it refers to these as above. Okay, so that's where those kind of come from. Standard in, standard out, standard error, that's the standard IO C names for file descriptor 0, 1, and 2. Okay, so what's a program? Well, a program, we're all used to this, at some level is just source code, right? We see source code in some language in there. That program could be stored as source code, which then would require us to do something to it. Or it could be stored as a binary, the machine language that ultimately gets read. So that would be post-compilation, post-compile then linking. So the difference would be whether or not something is a binary file that's already been compiled and possibly linked in a bunch of POSIX libraries or something like that. We'll talk about how things are linked here in a little bit at some point. Versus a script file which is interpreted and run in real time. So we've talked about these in the other various classes where we say there's 2 kinds of programming languages. We have compiled languages and interpreted languages. Remember those guys? So interpreted languages would exist as plain text source file, and they would get interpreted, for instance, by the shell. So the shell has its own little programming language, and it might interpret the contents of a file into the commands that it for whatever it should do. Whereas a compiled language like C requires that language somehow, through a compiler and a linker, translate into this new form, which is going to be in binary machine language type stuff. And that then gets run directly on the CPU rather than being interpreted by the shell. Understand the difference? Just 2 different ways of programs being represented. So this is where our assignment came from. So cat spit stuff out to the screen. What does grep do?
Searches
Okay, searches what?
for specific word, whatever you tell it to.
Okay, that's for what. So it searches, you said specific word, it probably takes regular expressions is what grep actually will take, but a specific word will it's a specific word is a very, very, very specific regular expression. Okay, if you're looking for the word hello, it will say anything containing hello as a very specific, but you could also say, I want anything that starts with a number, followed by exactly 3 characters, followed by a question mark, followed by, you can get as pretty fancy with regular expressions. But grep reads it's filtering on, or it's doing that searching on what input stream? Do you have to provide it an input stream? Or by default, does grep search standard input? Okay. So if I just come out here and I type in grep, okay, it's going to tell me how I need to use this guy, right? So I can say grep hello, and now it's waiting for something. So by default, it's waiting for me to type something in. So I can say cat, dog, hello, and notice it spit hello back out. It found a match. Make sense? So it's reading from standard input. So grep went into, okay, interactive mode. The alternative is you can use grep, and you've seen me do this before. When I can't remember the final git push command. So I'll do history, which gives me a list of a whole bunch of commands we've done in the history, and then I'll pipe that. So instead of the output going to standard output, I could redirect this to a file. But if I wanted to go in as input to another process, remember a little bit ago I said pipes are for sharing information between processes. I can pipe the output of history as the input to grep and do a search for push. And that'll show me all those things that match that. Make sense? So that's grep used in combination with a pipe and so on and so forth. So are you kind of wrapping your mind around how leveraging these things allows us to accomplish fairly powerful things from the command line? And these are things that it's not that you can't accomplish a subset of these with Windows, but Windows was never designed with the idea that you were going to interact with it like this. So this is kind of a feature of POSIX compatible operating systems. All right, what's TR? Translate? Okay, give me an example. What would it do? Weren't you also supposed to do that for the homework?
Yeah. So, for example, let's say you're looking for a specific character. You can replace all of that character with a different character.
Okay. So translate can take 2 strings. For example, utility copies the standard input to the standard output with substitution or deletion of selected characters. So you can provide it with the information that you want to do with like backslashes and stuff like that. So I don't use this very often, so I don't even know if I can give you a good example. So I can do a backslash, probably a... So backslash character, special characters.
You can just replace all spaces with tabs. Probably the best example.
Yeah, here's an example. So it's going to take file 1 as an input, so it's going to redirect the input stream from file 1, and it's going to go through and it's going to replace any... thinking this is what it replaces it with. So this is a carriage return line feed. And it's going to replace any collection of, I'm guessing alpha is a single alphanumeric. This one will replace all lowercase characters with uppercase characters from file 1, that type of thing. So interesting things you can do with it. And notice the command I put here was called man. This is the manual page. So if you do man space the name of any command, it'll give you how to use it in stereo instructions. Sort. Sorts. WC.
Word count.
Word count. So you can either do it on word or in character, things like that, right? Lines. Sed. Tiny little programming language. Okay.
Basically, it automatically does to a stream of text profiles that you send through it, whatever you want.
Okay. So it's a interactive text editor. The programming language that it supports would be regular expressions. I mean, that's this idea of a regular expression is describing patterns. That's what regular expressions are. Anytime that you've ever been working with any other programming language and we've like split stuff on a string, almost always that input is actually a regular expression. When I will say divide this up on commas, I'm actually saying divide this up on the regular expression that matches a single comma. If I want to divide it up on something more complex, I can build these crazy looking regular expressions. If we wanted to. So what sed lets us do, it's a stream editor. It allows us to interactively replace characters in an input stream or in a stream with whatever you've said to replace it with. Okay, and what about awk?
Pattern scanning.
Okay, pattern scanning, and from a constructive perspective, probably replacement stuff. So what's a good use for this?
The way I viewed it was sort of like sort range in Google spreadsheets.
Okay. Where I have found it most useful is if I have column delimited data and I need to, so let's say I have 10 columns and 8 of them are completely useless to me, and I need to spit out just 2 of those columns. And let's say it's using weird, maybe one thing we could do is we can copy it, paste it into Excel, and hope it could divide the columns up reasonably. But if it uses weird tabs or something like that, sometimes Excel doesn't know how to deal with it. So awk will handle kind of that same problem where it'll read in and then ultimately output just the portion of what you described. And then you can redirect that to a file. Then maybe you write a program that reads in from that file and only works with the columns that you really wanted it to work with. Something like that. All right, that kind of makes some sense. So that's just an example of some common programs. In terms of the ones that I regularly use, I use cat and grep often. The other ones, TR actually sounds pretty useful. It would be something that I would likely use often if I was more familiar with it. Sort I never use, I guess just because I don't run into problems where that's important to me, but I can certainly see where that's important. Word count. Sed is actually quite powerful for people who are used to working with sed, but it's one of those learning curve type things. Way back when, I used to do quite a bit of stuff with sed, and 105 or 106% of that is now gone. So, and awk as well, I didn't do quite a bit with awk, but I've done some things with awk before, and all of that's gone. So, but looking at a couple of examples, we could figure it out again, but this is a nice little grouping of some common Unix commands, and we can kind of see the power of having these guys all working together to solving relatively complex problems. Okay, and for Abe, we're back to process creation. So we have our POSIX compliant process creation system call, which is fork. And we have 2 different things that we're interested in as results of this. We have a process ID and a parent process ID. We're interested in an individual process's unique process ID and then a process that was forked. Abe. Okay. Okay. So a process that was forked, so a child process might be interested in knowing the process ID of its parent, PPID. Makes sense? Emphasis, Abe, on PP. Laughing at my jokes or Haxton's jokes?
Oh, that was yours.
My joke?
I was gonna say phrasing.
Christian worldview.
Said that.
How come you're sitting over there today instead of here?
I sat here the past when I was in Friday.
Really?
Yeah.
Isn't this, I'm not, I guess I don't want to tell you what to do, but I don't know if Haxton's like the best influence
Well, see, he screwed it up, and he wasn't sitting next to me before. Yentru was sitting next to me before, which I think that was good. Now,
I don't know. Everyone's changing it.
As an in-class presence, I would say Haxon is among the last person you should choose to sit next to if you want to be able to pay attention to class.
sit next to me, then.
You know, Nick's kind of breaking this up. I feel like.
No.
Yeah. Well,
You think large is better?
That's-
he pays attention. You don't pay attention.
I don't know about
That's debatable. The entire
No,
last
Largen
section
tries to
was
pay attention. He might have
He's not-
he might have an inability to really retain much, but he tries. You don't even attempt.
I contribute a lot more than a lot of other people.
In classes you find interesting.
Yeah.
So, what about classes that you don't find interesting? You either don't show up, or you sit there with like earphones in. All right, so that's your process creation stuff. So fork is a POSIX thing. So I guess we coupled those two things together. So process death. A couple different ways for a process to die. We can either commit suicide through the exit system call, which is a POSIX thing, or we could signal a process to die, which would be death by assassination. All right, so we can kill off, and we've seen this like on the Mac thing. If we ever click up here, you just saw me do it a few minutes ago, and I went up here and did force quit. You know, when I click on one of these, I'm signaling that guy to die. Okay, so I assassinated him. That's how it would get closed. As opposed to a process running to its natural, you go to File, hit Exit. That is going to raise an event inside of that program, and it's going to call the exit system call, which is going to clean up its process ID and release its memory and any other resource it's currently working on, close its open files, all that stuff. Okay, so two different ways for processes to die in a POSIX OS.
Didn't you go to lunch or something at some point with some work buddies sit right next to an old lady and you were talking about assassinating children?
No, it was reaping children. Yeah, this was at Western Illinois University. I'd written it was a server. It was in Perl, and as a new incoming connection came, it would fork new child processes. So we were talking about forking children. It was called Sunrise. It's like a breakfast diner type place. So we're forking children, and then we'd have a secondary process called the Reaper, and the Reaper would float around looking for abandoned children, and reap the abandoned children. So we're talking about this just passively at lunch, and this old lady sitting behind us and was getting very upset at our conversation.
Did you actually speak up at it?
Oh yeah. She came over and looked at us like we were sickos. She's like, I don't know what you young men are talking about. We explained it to her, and she said,
Shouldn't have. You should just be
like, look, lady, if you know what's good for you. Similar thing happened in this classroom. I think it was last year. I came in to teach one of my classes, and I was setting up, and there was two guys sitting here. I was like 15 or 20 minutes early, so most of the students, and I don't think any students had shown up yet. And there was two guys sitting here, and they were older, 40s, 50s, something like that, and I think they were photographers. But I didn't know that at the time. I ended up distilling that information. So they're talking about, I haven't shot homeless people in a long time. And so they're talking about shooting homeless people. I said, yeah, I still shoot them sometimes, but not very often. So finally, after the rest of their conversation, I start recognizing these guys are photographers, and they're talking about shooting as in taking pictures of people specifically, and I guess where the homeless people connection thing came in is they were involved with one of those the kitchens, downtown soup kitchens for feeding people, and we're trying to promote that and stuff like that. So they were talking about legitimate things that just sounded bad, like.
As opposed to the soup kitchens that aren't for feeding people?
No, I mean that they were talking about shooting homeless people. That aspect. That's what they were discussing is soup kitchens. And kind of helping promote soup kitchens. And in context of that, they were shooting homeless people in terms of taking pictures of them. But I came in at a bad time in the conversation is what ended up happening. All right, so here I mentioned this a little bit ago. This init process. So this is like the parent of all processes. So when your POSIX OS starts booting, the very first process is launched. That's this init process. So it'll be your very first process ID, and it's the guy that will then spawn off your. I think I mentioned it a little bit ago in terms of the 3 file descriptors for standard out, standard error, and standard in. So it'll do all that stuff. So this is a guy that's guaranteed to be running. I would assume if I come in here and I do top, we should see the init process somewhere in here. Oh, it's not actually on the top of my, let's do this. Control, so can I do PS? PS-L, and PS, I want to see system. These are all of my processes, so then can I do sudo PS? Oh, that's only within this terminal. Somewhere in the system there's going to be a list of all processes. I should be able to get the process ID of the init thing, but I suppose if you wait long enough, under this top command, you can see this is kind of the current, you know, the statistics going on with this. So here's the current things that are taking up system time on the, so here, Chrome is one of the guys taking up the most system resources multiple times. There's my terminal, whatever. So, okay. So in any case, that we know that guy exists. So we have this important process that if we were to assassinate the init process, chances are modern POSIX OSs probably have a way of recovering from that or block it. But if you could find a way to assassinate the init process, that would be detrimental to the OS continuing to run or require a reboot. Daemon processes, as in Matt Damon, of course. All right, so there's nothing special about a daemon process. Just kind of talks about the it's a naming convention and also kind of the nature of it. So typically these guys start when an OS boots, but that's not always the case. So for instance, most of our servers we might run if we decide to configure our own web server that runs on a different port than the standard port. That might be something that we start up and shut down very much. Much later after the OS has booted. A good example might be like Node.js. We start the Node.js server over and over and over again whenever we're writing Node.js software, and that would be a daemon process that didn't launch during boot. So this is more of a general catch-all saying it typically starts with a boot. It runs in the background, and more importantly, it's not associated with an individual terminal. All right, so all of the things that we've been running from the terminal kind of are linked to that terminal. So when they do standard output, the standard output specifically goes to the standard output of that terminal. Okay, so a daemon would not be linked to a terminal itself. Otherwise, it's the same as a normal process, although if you look at a couple of examples here, this would be like the standard HTTPD. This is the Apache daemon. Notice that daemons tend to end with the character D. It's not a requirement, it's more just a convention. Okay?
You've seen Team America, right?
I have. Yeah. What just happened? Something happened? Matt Damon. All right, so then we have this thing called the environment list. So every process, and this is a relatively new thing, so this would have been introduced not in the original POSIX standard, but I guess since then, every process lives within its own little mini environment. So it has a list of environment variables that it would have access to. So think of environment variables like global variables, maybe associated with certainly associated with a terminal, but also could be associated with, so if you think about, when we open up a terminal, we think of that as our actual operating system, that's going to have its own environment. So that terminal was a command itself. So it has an environment list associated with it. So it maybe the bash command, for example. And in that environment list, there could be a bunch of different environment variables that are defined. Okay, so these would be like global variables that we could access within any of our programs that we write or anything like that. Similarly, if we have our own program inside of that we write and launch from within inside of our terminal, it would get its own more local scope environment list where it could have its own environment variables. Most importantly, I guess for us, from a C programming perspective, is we get access to that environment list in our current environment through this char pointer. Okay, so for those of you who have ever done any C or pointer stuff, what kind of animal is this guy? And maybe don't read the line above it. You cannot unsee what you've already seen. All right, so a char pointer is how we reference a string. A char pointer is how we reference a memory address of a character. So we have two different types of memory addresses for characters here. One of them is the beginning of an array, a character array, in this case a string array. So the first thing is we have a char pointer. That is a pointer to the beginning of an array that contains char pointers. That makes sense? So bucket 0 of that array will have a char pointer in it, which will be the first character in a string. And the array itself is an array of char pointers. So every bucket of that array points to a string here, or a string here, or a string over here, somewhere in memory. So whenever we see 2 stars, that's typically an array of something. In this case, it's an array of strings. You would also see this in older C programs. When you look at the main method, it would be like int main. It would be int argc, that's the argument count, comma char pointer argv, the array of argument values that were passed in. That's an array of strings. Okay, and that would be, those 2 parameters put together would be equivalent to the Java string array args.
Are we not allowed to use the string libraries?
Well, string libraries don't necessarily exist in the original standard C. You do have C strings, which sort of kind of exist. I don't think they're part of POSIX, so let's just assume right now no. And standard template library is a C++ thing, so you definitely don't have access to that as POSIX. So, but unimportant for us. I mean, char pointers are fine. It'll actually be good experience to, manipulate these scary things that are not that hard. So some library functions do allow you to modify their environment list. They would expose through a function or something like that access to their environment environ variable. So you can make modifications to it or something like that. Okay, resource limits. The OS itself does define kind of a standard template for what is the maximum resources a single process can access. But beyond that, we can also set limits on a per process basis. So resources are going to be open files, memory, CPU time, things like that. Any sort of upper limits on what a single process is allowed to do. We can do a set our limit system call to allow a process to set its own limits. Whenever we fork a child process, that child process that inherits many of the traits of the parent process, including any resource limits, it also inherits, I think, file descriptors. Any open files that process has as well, which is a way that it can handle inter-process communications, kind of specialized inter-process communications specifically between a parent and a child. So we might have multiple completely separate processes on the OS that could deal with shared memory or something like that for communicating with each other, but as a natural byproduct of forking, child processes have a built-in communication channel to the parent process in that they share all the resources that were already open in the parent process. So if we open a file in the parent process, the child will have access to that open file, for example. Okay. Memory mapping. So this is the mmap. So every process kind of has its own virtual address space, similar to how a process has its own environment list. So we have the ability to map memory. So we have, so think about this at kind of at the high level for us. We can either create a file descriptor directly into like a certain region of a file. If there's a portion of a file that we need to either read or write from, or later on we're going to talk about file locking, we can protect. We can do that. We can also just create blank memory that we want to use. So a process can just map some new unused system memory and say, this is now mine. And then it can, if other guys can be shared that, then now that's a good way of sharing information. So that's the anonymous mapping versus file mapping. So let's just stop here. So remind me that we're on the memory mapping slide here. No homework assignments for Monday because many of you are in senior SEM and should be working on your idea paper. All right. So I will see everybody on Monday.